Now we'll be walking through an example on how we can use the deep learning algorithm to solve a basic problem. So I have this CSV file, read-1.csv, which has a number of physiochemical measurements from about 1600 Portuguese red wines, and also included is a quality rating from blind taste testers. So the goal of this example is to find out what the what are the optimum physiochemical measurements is and how does that produce a good quality red wine. So in order to do that, let's first run this cell of code to display the first few rows of this dataset, and we can get the number of rows and columns of a data frame or a NumPy array with the shape attribute. So if we just run this function, we'll get the number of rows along with the number of columns, and that will help us to determine like what is the appropriate number of neurons and number of layers to use. So next we will define a linear layer appropriate for this task. So pay attention to how many inputs and output the model should have. In this case, the inputs will be about 11 since there are 11 characteristics in total, not including the quality of the red wine, and we want one single output how good the quality of the red wine is. So let us define a typical three-layer deep learning network with over 1500 neurons, and it should be capable to learn some fairly complex relationships in this data. So we define a model which is three layers, three hidden layers, and one output layer in total. The three hidden layers each consisting of 512 neurons and each using the ReLU activation function with an input shape of 11 neurons. So after we define the model, then we define the optimizer loss function using Adam as the optimizer and MAE as the loss function. And now we're ready to start the training. So we've told Keras to feed the optimizer 256 rows of the training data at a time. So that would be the batch size of size 256. And we go through the training data set a total of 12 epochs or 12 times. So now we can just run this model. Oh, wait, I'm sorry. I should have ran this thing first, create the model, compile the model with the optimizer, and then run the model. So as you can see, KRS actually shows us what happens in each step of the way, how much is the loss, and how is it like getting closer to the optimum loss, which as we can see plateaus at about 0.1. So as we go through, we see the loss value being updated as the model trains, but oftentimes it's kind of better to see how the model progresses using a line graph. So the way better to visualize this is to plot it. And the fit method that we used just now, in fact, keeps a record of the loss produced during training in a history object, and we can convert that data into a pandas data frame, which makes the plotting easy. So now if I use the history and plot the history, we can see the loss value of our training dataset getting closer and closer to the optimum loss value. So we notice how the loss levels off as the epochs go by, and when we get to that plateau, it means the model has learned all it can with the inputs that it has, and there will be no reason to continue with any additional epochs.